हाँ लॉगिन करो।
सर आवाज़ नहीं आ रही है सर।
ओके, तो सब आ गए हैं ना? ठीक है, अमित कुमार, ओनली अमित कुमार
हेलो।
इज देयर। हाँ, अभी स्लाइड आ रहा है ना? स्लाइड इज विजिबल, अमित कुमार। अभी आपको स्लाइड दिख रहा है? हेलो। आई एम ऑडिबल और नॉट? ओके ओके। नाउ इट इज ऑडिबल, अमित। जस्ट अ मिनट। इज इट ऑडिबल नाउ? हेलो, इज इट ऑडिबल नाउ? Now, is it audible?
जी सर, आ रही आवाज।
अमित
जी
आ गया ना?
सर, आ रही आवाज। हाँ।
ओके 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 ओके, ठीक है, अभी स्टार्ट करते हैं। ऑलरेडी थोड़ा लेट हो गया।
यस सर।
सो स्लाइड विजिबल, अभी विजिबल है ना? अभी स्लाइड्स आ रहा
विजिबल
है?
है सर। जी सर, आ रही है।
ओके ओके ओके, ठीक है। अभी थोड़ा बेसिक्स ऑफ जीआईएस जो है उसको डिस्कशन करते हैं। सो व्हाट इज जीआईएस एंड व्हाट इज द डिफरेंट कंपोनेंट ऑफ जीआईएस, then different software, hardware, and other parts of the GIS. So the GIS system that is composed of hardware, then database engine, and designed to efficiently assemble, store, update, analyze, manipulate, and display geographically referenced information. The geographically referenced information is like that. So in the GIS platform, we just cannot use any information in the GIS platform. So with the help of geographical location information like latitude, longitude, and elevation, we get the data, then georeferenced it, and with the help of different softwares, then we use this photograph or any other images. So without any georeference data, we cannot use this data in the GIS platform. So we can store, update, analyze, manipulate, and display all the reference data. So the GIS also include people operating with operating the systems and data that goes in the system. The component, there are various components are there in GIS, that like hardware, software, people, and data. So in the higher hardware part, that is computer on which a GIS is operated. Today, GIS software runs on a wide range of hardware like hard disk and centralized computers, laptops, also in the mobile system, also in the smart mobiles and standalone. Then software. Then so for GIS operation, we need a very sophisticated and highly updated softwares, and softwares are provide functions and tools needed to store, analyze, and display geographical information. So basically, in the geographical information system, we just collect the data based on the Earth surfaces of very different type of landforms. So tools for the input and manipulation of geographical information in database management system. So lot of programming DBMS are there, like SQL and other databases are there, which are used in the GIS software using different softwares. So tools that supports geographical queries, analyze and visualize. So different tools are there, different programming, different scripts are used in our softwares. Then another important parameter is the data. So most of the important thing about the GIS is it needs a reference data and a normalized data. So geographical data related to tabular data can be collected, which have the information about different geographical location or different parameters like temperature, humidity, and wind informations for particular locations, and also some plot informations and some forest area informations, forest species informations. So, so these type of data which are collected in the form of Excel or other different formats. So this GIS based software integrate all these non-spatial data into the spatial data with the primary key, which is common to both the spatial data and non-spatial data. Then it is integrated with this all related data. then we use all this uh, database. So most of the organization maintain their data to manage spatial data. So after that, data is very much important in the GIS system, and which type of data is available in our applications is very much important. Then GIS technology also limited without the people who manage the system and develop plan for applying it to the real world problem. So people, I think, people like the GIS experts and other analysts, which are using all these softwares and all this data, uh, तो उसका भी थोड़ा एक्सपर्टाइज होना चाहिए, नहीं तो नहीं मिलेगा. But GIS users ranges from technical specialties who design and maintain the system. Some of them are very good in data survey, and some are in the image interpretation, and some are in the programming. So, different expertise are there in the GIS field. So by integrating their work in a common platform, we use a significant application which is useful for different field. So hardware software have some tremendous development which made people easy to run the GIS software. So nowadays the hardware technology is gradually developed, and software technology also developed in a tremendous way. So different programming languages are also available for different application in the geospatial technology. After that, that is the method. So which method is useful for different applications? So it is decided by JS expert and application expert, and the user requirement is also there. So for any research purpose, we use different models. For example, for atmospheric studies, there is a different model is there. For hydrological studies, there is also hydrological model is present in the ArcGIS software. And for urban planning, there is a different model. So different models are used for different applications. What the main thing is, the first is the data, which type of data is available, how these data are fit into the model. So the important thing is the the data accuracy is very much important, which are input for the model and which gives the better output for different applications. So a lot of models are there, and a lot of models are also in the Google Earth engine or different software. The integrated models are also present. Then these address different questions about the methods, number of exports required for different applications. So the different components of this JIS is, first is hardware, then software, then data, then people, and then method. The five components are very much important for the GIS uh, analysis. So it is also in most of the time asking the questions, what is the component of GIS? Just elaborate it briefly and given some examples. So you can write all these hardware and software data, people, and method. Data you can also give the example like spatial data, like Excel data, which is information about the latitude, longitude, and the hydrological information, and the spatial data like satellite images and GPS informations, survey point, DGPS informations, and topo sheets, rectified topo sheets. These are some example of the georeference data. Then people, a lot of experts are there, a lot of researchers are there. Then methods, different methods like AHP method, then other urban planning models are there. So you can give this examples and softwares like ArcGIS, NVQGIS, and QGIS, NV, and AirDAS is all one of the softwares which is also used GIS applications. So these are some brief about the component of GIS. Then data in GIS. So various type of data are there in the GIS applications like spatial data and non-spatial data. So the spatial data are which are space-based information, that is georeferenced data or not georeferenced data, but it is about the geographical entity which are in different form. Then spatial data is categorized into three different area, that is vector data, then raster data, then team data. Then vector data, which is categorized into three category, that is point, line, polygon. So vector generally we use in the softwares to draw line, point, and polygons. So these are the vector data. Then raster data, that is grid based data, and some image, satellite image or other images are there. So these are the raster data. Then teen, previously also discussed to you about the teen, that is a elevation related information. It is full form is triangulated irregular network. So all these elevations are in the form of triangle. So these are the spatial data. Dem data also is spatial data. Teen or digital elevation model. These are all space-based data. So basically the spatial data which includes vector, raster, and teen. Then non-spatial data which are not the space-based data. It can be in join with the space-based data like different Excel data, that nominal or categories, ordinal range data, interval ratio, cyclic count, and amount. These are some techniques, and these are some non-spatial data. So in the raster data, the raster is composed of some pixel value. So each raster has a unique pixel. Just a minute. Each pixel. So there is a pixel based informations are there in the raster data. Then vector is basically for point, line, polygon, and the real world data which is available. Then vector data. Then in the vector data, we are allowed to specify specific spatial locations, assumes their geographical space is continuous. So generally, vector data are rectified data, that is georeference data. Without georeferencing information, we cannot use this vector data, and it is not useful in the GIS platform. So in every vector data has the latitude, longitude information. Some have area information which are in the polygon. So we store feature set of XY coordinates. So in the vector data, we are stored in the XY coordinates. So for line, there are, when we are drawing a point or line or polygon, so there is a vertex. The minimum unit is the vertex. So with the use of this vertex, we use drawing different line, point, line, polygon. So this is one of the satellite data, high resolution satellite data. It is the Sentinel 2 image, satellite image. So we can calculate the spatial resolution of this satellite. So it is composed of each pixel. So these are some pixels they are used. So it is a raster data. So it have some pixels. So if I want to know what is the spatial resolution of this satellite, then we can measure the distance of pixels in the term of meter. So it is a 10-meter distance. So this it is a 10 meter by 10 meter pixel. So the resolution of this satellite is 10 meter. So Sentinel data is 10-meter resolutions for specific bands like band 2, 3, 4, and band 8. These have the 10-meter spatial resolutions. So you can calculate any uh, satellite spatial resolution by measuring tool using this unique pixel. So this is the raster data, and this is a vector data. This is a vector data. So there is no any pixel information. We can zoom it. So there is no any pixel, only the boundary line. So we cannot find any pixel information in the vector data. Okay, then to the slide. Then point in the vector data there is point, line, and polygon. So point is a zero-dimensional abstraction, and it has no dimensions. So the point normally represents geographical features through small display in a line and area. So it represents the geographical location like latitude and longitude. Like just there are some points are there. There are some points. So it signifies some survey data or some latitude longitude informations. So we can get the latitude longitude information. So by clicking this, we get the latitude longitude. So this is the latitude and longitude information of this point file. So it has no elevation information. Otherwise, it is also shown the latitude longitude along with the elevations. So this is the point file. So point file maybe signifies the hydrological informations, well data like well data or some well depth data or some building locations, some different buildings in urban areas or some other eco-sensitive zone or some different important locations informations. So this signifies some point related informations which are very accuracy in the form of locations. So points, so every point have some IDs are there. So every points have a unique ID, that is FID. It's a unique ID is presented along with some database is generated. So all these are the attributes of this shape file. It is a attribute information. So we can get all the information related to this point file, point or polygon or line file. So we can also join a lot of uh, non-spatial data if there is a common information is there. Then there is the point file related informations. Then the polygon file. So polygon file has a different application and lot of informations are there. So we can draw different area, different classification like land use land cover classifications, cloud area mapping, and forest area mapping, water bodies mapping. We use the file. Point file also some attributes like the polygon file also have some attributes which are similar to the point file. Generally, polygon features have two separate parts that can be potentially be modeled in 3D: their exterior perimeter line and their interior area. So there is a perimeter and there is the interior area. So we cannot draw one polygon inside this polygon. So there is some topological errors are there. So nearly all instances, polygons should be modeled as 3D features only when the exterior perimeter needs to be include Z value. Example of 3D polygon features are which includes lake boundary, building footprint, street. A lot of examples are there within this polygon. Then similarly, the lines which are also useful in the making of the drainage or uh, any road network. Then there is an important thing about this that there is a need of topology information. So without any topological relations, we cannot draw point line polygon in a correct way. So topology describe the spatial relation between the adjacent features. So which polygon will be adjacent to this? Using such structures enforces planar relationships, allow GIS specialists to discover relationship between data layers. So for any one polygon, so one information is there, one row is there. So if for one polygon, if multiple rows are there, then it is a error. Like some example is there. Suppose this is a polygon. This is one polygon. This is one polygon. So each polygon has unique attribute. There is a unique attribute for each polygon. If it shows multiple polygon, then it is a error. Suppose I click this polygon, then it shows two attributes, two row, two informations are there. So that is a topological error. So for other polygon, there is a one row, and for other the rest of the polygon, there is one row. So it shows the two rows that which is a error in our special attributes. Okay. Is it visible to you? Hello.
Yes, sir. Visible.
It is visible. clearly or not visible clearly? This RGS software. Okay.
Yes, clear,
Then
sir.
okay. It can also be defined as topology, and that is collection of rules that couple with a set of editing tools and techniques and enable the database to more accurately model geometric relationships. So provide an automated way to handle digitizing and editing errors and artifacts. So reduce data storage for polygons because boundaries between adjacent polygons are stored only once. The same thing is written. Enable advanced spatial analysis such as adjacency, connectivity, and containment control. And another important consequences of the planar enforcement is the map that topology content space filling. So these are some errors. If there is any space between the two polygons, then that is a topological error. And if the adjacency is okay, then it is okay. So this is also a gap present in between the two polygons. So this is also give the topological error. So topology is very much important to analyze the data. Some of the software have the topological analysis tools there to give the correction of this topological error. So generally topological error means the geometry of the polygon. So if the geometry of the polygon is wrong, then we have the wrong information about this uh, point line polygon informations. So topology can correct all these geometrical errors so that we can get the accurate information. So topology has been a key GIS requirement for the data management and integrity, and topology is fundamentally used to ensure data quality of the spatial relationships and to aid in the data compilations. Topology also used for analyzing spatial relationships in many situations such as dissolving the boundaries between the adjacent polygons with the same attribute values and traversing a network of elements in topology graph. So these are some examples which are also seen in this our software point line polygon, and these points are some well data, and the polygons have some district boundary, and the well data distributed in different districts are given in this map. Then raster data, this is based of the pixel values. So each pixel values has some DN number, that is digital number. It can be some reflectance information or some elevation information. So for DEM data, it get the elevation information. For other satellite image, that is the reflectance information from the sun. So data is classified as continuous and thematic, and raster data reference features such as matrix of cell within rows and column. So these are the arranged in the row and column form, and they have some specific dimensions also. So the first is the pixel based information data. Second is the digital elevation data, which is in the black and white form. And the white patches which are shown in these images are the highest elevation, and the black patches are lowest elevation. So it gradually increase the elevation from black to white portion. So white pixels have highest elevation information and black pixels are low elevation information. So image based data, a lot of image based data are available, like a satellite image in the form of color or black and white image, and then aerial photograph, which are high resolution satellite image, high resolution images. Then Google Earth is one of the highest resolution satellite image having 5-meter spatial resolutions. So it is also 46 to 50 centimeter uh, pixel information. So these are some example of the image-based data. So some of the image-based data are mm, mm, a unit is called as pixel. So every image has some pixel value, but some of the grid information data are also there. So their unit is cell. Each cell has some information. Pixel have some positive integer. There is no negative integer that is starting from 0 to 255 or 1024 according to their bits. It is 8-bit or 16-bit satellite data. If it is a 8-bit data, then its pixel value ranging from 0 to 255. So likewise, the grid, both positive and negative integers and the real numbers are also there. Spatial resolution. So spatial resolution just I shown in this software that what is the pixel width, what is the dimension of the pixel. If the dimension of pixel is 3 into 3 meter, then the spatial resolution is 3 meter. So if the spatial resolution is very high, then image clarity is very much high. If the spatial resolution is low, then image has a very blurred type of image. So it is not clear as compared to the high resolution data. So there are three satellite images, that is 1 meter, 10 meter, and 30 meter. So 30-meter resolution data means it's not working for any urban applications. It is for different geological applications and other forest area mapping. So some of the satellite images measure in the arc form. So there's on the list is there. So 1 degree is 110 kilometers. Then 1/3 arc second, it is 10 meter. So this satellite image is a 1/3 arc second. So generally in the form of vector data and raster data, the real world is represented in some of the raster data, which is grid based data, and this also represented in the vector data in the XY coordinate system. So we can interpret all these satellite images with the help of vector data. Then we get the map. And what is the advantages of vector data and raster data? The accurate positional information that is best for storing discrete thematic features, that is road, shoreline, seabed features. We can draw with the help of different satellite images. Then compact data storage requirement. The most of the satellite data is very large and bulky. So in the vector data, we can create same level of information and create the map, which has very less memory as compared to the satellite data. Can also associate unlimited number of attributes with specific features. So we can add a lot of features, a lot of information, and unlimited number of attributes in the vector data. But the raster data is very mm, strict data, that is not editable, or it cannot be mixed with other data. So most of the common raster data is TIFF format and in some ARDAS format and JPG format. But in raster, is one of the advantages is we can perform mathematical and overlay operations That is supervised and unsupervised classifications. We can use this supervised classifications in the raster data, as this data is different BN number and different reflectance value. So based on these values, we can categorize all these features with the supervised and unsupervised classification techniques. So it is not as much as possible in the vector data. So it is also perform mathematical and overlay operations. So satellite information also easily incorporated in this information, like we can get the mm, thermal information from thermal bands with the help of the raster data. Then vector represents continuous data, because the raster data is not discontinuous, so it is a continuous data. So the difference between the raster and vector is the raster divides data into grid cells and the vector use point line polygon. So this is the different basic difference. So in the grid cell, there is a faster processing system and easy to integrate with remote sensing data. So remote sensing softwares like NV, AirDAS, these are mostly used the raster data like satellite data. Then in the GIS form, we can use vector point line polygons with the help of this raster data. And raster is simplest to store in different computer, and point is represented by single cell. A line is represented by the group of neighboring cells. Set up a rows and columns. So generally, the rows and columns are available in the raster data, which is not present in the vector data. And each cell is assigned a value as per the requirement of the satellite. So in the vector data, generally the boundary is very neat and clean, and its maps are very much clear. We can changes the colors according to our requirements, and point line polygons are very much um, clear. So this is a basic, very flexible data. We can edit very much easily, and we also registered this vector data with the help of different GPS points. Then the raster data, when we convert the vector data into raster data, then generally this vector data is converted into raster based format. So there is some example of the raster and vector. That is, the vector data structure is very much complex, and raster is very much simple. So generally, this type of questions are asked in the exam. What is the difference between the vector structure and raster structure? So each of the difficult software is complex, and easy function are tend to more intuitive than vector. But in the vector form, there is a precise informations are there, but precise increase with increased processing time, and the depending upon the software and data available, if it is a high resolution satellite data. So we can get the polygon line and points information from vector data, but raster is a good for continuous data and limited for the size pixels. So queries related issues are not there in the vector data. We can get the different queries and relative simple data analysis and export it easily. But the raster queries is very much different. Different mathematical models are used to get the information. Then storage, it is a small data in memory form. What is a large memory data? Then vector data is very much easily handled, and raster data is structured, so it amendable to network. So maps are very good in the vector form as compared to the satellite based informations. So generally maps in the vector form is very good in neat and clean, but in the form of the raster data, in the use of the raster data, the map like supervised and unsupervised classification informations are not as clear as the vector data. So vector data to conversion to raster data is some functions are there. L is equal to f1 x1 is equal to f2 x1, and raster to vector is x is equal to function of L and E, and the function of f into L into E. So where L is the scan line, E is the element pixel number within the scan line, x is the horizontal coordinate of the GIS system, y is the vertical coordinate of the GIS system, and f1 to f4 is the polynomial function derived by the least square analysis. So some mathematical analysis are there to convert this uh, system, but in our software it is easily convert by different tools which are used. So when we convert this vector data into raster data, the clarity is missing, and the clarity is very less when we convert into the raster data. Along with when we convert the raster data into vector data, we also get some low accuracy data. So there are some fact that the raster is faster, but vector is corrector. When we use the raster data, generally working with continuous data type, elevation, for elevation we use the raster data, but sometimes we also use vector data like contour lines, which are also present in the vector data. Then slope from the satellite and the satellite photograph, good for the large area analysis. For the large area analysis, raster data is very much important. Then good for surface analysis like hydrological analysis, then flood analysis, urban sprawl mapping. So these are the very much important for the raster data. Then mathematical modeling like supervised classification, unsupervised classification, then different other NDVI calculations are there. So NDVI, then NDBI, different index calculations are easily calculated with the help of raster data. Then special details is not important. Sometimes special details are not important, like what is the latitude, longitude informations. So in the vector data, it is useful for the discrete data type like trees, particular building, property boundary, along their locations with high accuracy, good for small study area. So basically, GIS also used for larger areas. GIS, sorry, vector are used for large area, but generally it is used in small area like buildings informations and tree species information. Then special details are more as compared to the raster data. We can get more and more information, and we can update all the informations and add some all information in the vector data. And it's really good according we can use the data as the user's requirement, and the topology needed for the analysis. But in the raster data, there is a no topology related information is there, as this is a discrete continuous data. But in the vector data we can use the topology, so it can be there topological error, or there is a gap between two vector polygons. Then dam structure. So generally, thin triangulated irregular network is a dam digital elevation. One of the digital elevation information is there. Then some of the elevation are raster grid informations are there. So SRTM DEM data is raster grid related informations. Then TIN data, we can create DEM data with the help of TIN, with the help of our elevation information in the line format. So regular grid may not be adapted to the complex of the leaf so that an excessive number of data points is needed to represent the terrain to a required level of accuracy. So these are the example of that raster and tin which are give the elevation information. So primarily the Delaunay triangulations methods are used in the tin data informations. So according to the mathematicians Boris Delaunay, it is called as Delaunay triangulations. So in this method generally uh, minimum 2 points are sorry minimum 3 points are attached to a circle. So every 3 points creates a circle. So another every 3 points are creates a circle. So this type of methods are used for elevation information. So with the help of this tin data, so this type of elevation informations are created. Then after processing, then this surface-based informations are there. So we can create this type of features. So we can create tin data from the contour information. So generally in the topo sheet we can create contour and we can draw contour. So also by the survey we can also get the contour line. So with the help of this contour line we can create tin and we also create some slope, aspect, hillside, planimetric area, surface area with the help of tin data. So tin and raster is different thing. Tin we can create from point, line and polygon, GS vector data. And raster are generally satellite data which have the some elevation informations. So the advantages in the tin is efficiency in the storing. It is low storage information, low storage data. It is a high database information is there. But in it has also disadvantages. That is, it requires some visual inspections and manual control of the network. So ability to use various grid size to reflect areas of different complexity of the relief in the raster data. So generally the raster data is very smooth and very uh, good in surface information locations. But tin data, it's a very complex thing, and it can be give the error. So with the help of this point data, we can get the tin data, which the point data is elevation data. Then we can get the slope. Then we get this aspect. Aspect is one of the mm, important thing that is defined as the downslope direction of the maximum rate of change of the value from each cell to its neckboard. So when the elevations informations are gradually decreases from some one-sided, then the aspect map is calculated. So which side that is a downslope and which side there is upward. So these directions are signifies in the aspect map. So after that, some six kind of basic attributes that are used in the GIS mapping. It is nominal, ordinal, intervals, ratio, cyclic, counts. So nominal means just the simplest type of attribute describe name and some information. name, mobile number, or any other different online informations. And some of the examples are some land use categories. So forest area, crop area, scrubland area. These are some categories. And this name of the house. These are some nominal data. Then ordinal and rank data. So in this rank data, there are three or four ranks are there. So it is some is higher first order, second order, third order. So in the drainage pattern also, there are first order drainage, second order drainage, third order drainage. So first order drainage join to get the second order drainage. So this type of order formations are there in the ordinal data. Then interval. So interval is generally used in the temperature informations in that climatological data. So this area temperature is from 20 to 30 degrees. So this is the range. So this interval is there, and rainfall data also some interval data. These are type of interval data are used. Then the ratio, some characteristic of interval variables are also there, like weight is one of the ratio. So something is 10 kg and anything is 20 kg. That the 1:2 ratio is there. So for any tree height informations, we can get the information about the ratio. So these trees are 1.5 times bigger than other trees. So this type of ratio data are useful for different applications. Then direction or cyclic, and sometimes necessary to deal with that data can be directional. Cyclic includes some flow direction on the map, the flow direction of the river, flow direction of the drainage pattern. So this is called the directional data. Then counts and amounts. The counts and amounts something this equal number of features on the map. Suppose uh, population data. So some district has high populations, some district has low population. So this population based map is also considered as one of the counts related and amounts related data. So this is one of the example. The city has the different temperature information. Sorry, this is a population information. So the red gives the high population. So this is one of the example of the counts. So this is for the today. Next time we will discuss all the different other aspect of the GIS, basic GIS, and other software and other techniques which are used in the GIS platform. So these are some basic information about the GIS field, what type of data are available in the form of raster or vector, or how can be arranged in topological sequences. So I think it is completed, and next day we will discuss another chapter of this GIS. Okay. So any queries?
हाँ सर, मुझे पूछनी थी, मैं वैसे हिंदी में पूछ सकता हूँ सर?
हाँ हाँ बोलिए।
हाँ सर, जैसे हम मेरा बेसिकली काम डैम का ही है।
हाँ।
सेंट्रल वाटर कमीशन में मैं डैम डिजाइनिंग में हूँ।
हम्म।
तो सर मैं ये पूछ रहा था कि जैसे आपने रास्टर डाटा और ये इनका बताया,
हम्म।
तो लास्ट में आपने वो डैम का वो बताया था कि डैम डिजाइनिंग के लिए ये मतलब उसके आसपास का जो हमें वो देखना होता है, जैसे बेसिकली हम कंटूर पे काम करते हैं,
यस।
एनएसएल कंटूर।
हम्म।
तो अगर हमें किसी एक स्पेसिफिक एरिया का पता करना हो, जैसे कि डैम के आसपास कितना मतलब कंटूर का लेवल ऊपर है, नीचे है, डाउन है, तो उसके लिए क्या कैसे करेंगे सर?
देखिए, आपका डैम का डाटा आप कहाँ से लाते हैं? मैं सॉरी,
डैम का डाटा तो
कंटूर कंटूर का डाटा।
कंटूर का डाटा तो स्टेट से आता है, जिस स्टेट में डैम बनना होता है वहाँ का पूरा डाटा
हाँ
आता है, और
हाँ, तो
पिछले
डैम
तीस
का,
बत्तीस साल का
हाँ मैं समझता हूँ, जो डैम का डाटा, सॉरी कंटूर का डाटा आप लाए हैं,
कंटूर का।
वो तो बेसिकली टोपोशीट से क्रिएट हुआ होगा।
जी।
हाँ, तो उसमें अभी जब टोपोशीट्स जॉइन करके उसको सब जॉइन करते हैं, उसमें भी थोड़ा एरर आता है। तो आपका कंटूर कितना हाई एक्यूरेट है, उसको भी देखना पड़ेगा, और कंटूर का क्लोजनेस कहाँ पे है। अगर क्लोज है ज़्यादा, देन इट इज़ एलिवेटेड एरिया। तो आप जनरली डैम डाटा कहाँ से क्रिएट करते हैं, जो एसआरटीएम डैम?
आपने ये
एस
टीम डैम का बताया था।
हाँ, टीन टीन से भी तो हम कंटूर जनरेट कर सकते हैं और डैम भी कर सकते हैं।
अच्छा।
So contour generate contour also converted to tin. Then this tin also converted to DEM data. But some of the satellite data surface information is very good. ये अभी जो फ्रीली अवेलेबल है, एसआरटीएम का डाटा 30 मीटर का एक्यूरेसी है। देन और एक है सेंटिनल का 12.5 मीटर स्पेशल रिजोल्यूशन है एलिवेशन का। और एक टेक्निक है गूगल अर्थ में, हम गूगल अर्थ से भी हाई रिजोल्यूशन एलिवेशन इंफॉर्मेशन क्रिएट कर सकते हैं। तो उसमें थोड़ा सा आपको डिफरेंट साइट्स है, उसमें आपको अपलोड करना है आपका डाटा। देन उसमें आपको 1 मीटर एक्यूरेसी का एलिवेशन भी आ जाएगा। तो उसको मैं कभी डेमोन्स्ट्रेशन में दिखा दूंगा कि हाउ टू गेट द एलिवेशन इंफॉर्मेशन फ्रॉम गूगल अर्थ, गूगल अर्थ इमेज फॉर
जी सर,
स्पेसिफिक।
हमारे पास जो डाटा आता है वही 1 मीटर, 5 मीटर या 10 मीटर में ऐसे आता है सर।
अच्छा अच्छा, तो बेसिकली आप क्या मतलब किसको आइडेंटिफाई करना चाहते हैं?
मतलब मेरा क्वेश्चन ये था सर कि जैसे हम जिस एरिया पे डैम बनना है उसके
हम्म।
आसपास का जितना भी वो है, मतलब 5-7 किलोमीटर का एरिया,
हम्म।
वहां पर हम इस डाटा के हिसाब से वो पता कर सकते हैं कि कहाँ पे नाला, मतलब पानी है, कहाँ मतलब ऊंचाई है,
देखिए,
पीक एरिया है।
हाँ पीक एरिया है, आप जान सकते हैं, लेकिन इसका मतलब नहीं है कि उसी से कुछ ड्रेनेज क्रिएट होगा। हो भी सकता है, नहीं भी हो सकता है। उसको तो फील्ड विजिट करना पड़ेगा। आप एक इमेजिनरी लाइन क्रिएट कर सकते हैं।
फील्ड विजिट तो होती है।
हम्म। नहीं, आप जनरली एक काम कर सकते हैं, आप जो सैटेलाइट बेस्ड एलिवेशन इंफॉर्मेशन आता है ना,
जी सर। जैसे
उसमें
किसी
थोड़े,
रिजर्वायर का भी पता कर सकते हैं कि इस जगह पे ना करके इस जगह पे रिजर्वायर बन सकता है।
हाँ रिजर्वेयर के लिए अगर ऑलरेडी एग्जिस्ट है या न्यूली क्रिएट करना चाहते हैं?
मैं तो सिर्फ इतना पता करना, मतलब अगर इस डाटा से हमें, मतलब इस सॉफ्टवेयर से ये पता चल जाए कि इस डैम के एरिया के आसपास और कितना वो है,
हाँ,
मतलब हाइट और लोड
देखिए,
है।
हाँ मैं समझ गया। आपका जनरली चाहिए एक आपको सैटेलाइट इमेज जो हाई रेजोल्यूशन सैटेलाइट इमेज, और 10 मीटर रेजोल्यूशन सैटेलाइट भी चलेगा। उसको
जी।
उसको बैकएंड रख के बेस मैप बना के आप जो एलिवेशन क्रिएट करते हैं, उसमें आपको देखना है कि अगर कोई किसी भी जगह पे आपका जो कंटूर लाइन ज़्यादा क्लमजी आ रहा है, और और इमीडिएटली उसके पास थोड़ा मतलब गैप आ रहा है, तो आपको पता चल जाए कि इस एरिया में थोड़ा फ्लैट एरिया है, और आप उसको चूज कर सकते हैं फॉर एनी चेक डैम कंस्ट्रक्शन और एनी डैम कंस्ट्रक्शन। बट उसके लिए तो थोड़ा जियोलॉजिकल स्ट्रक्चर भी देखना पड़ेगा कि इसमें डाइक है ना या नहीं, ड्रेनेज पैटर्न कैसा है।
जी
बहुत
सर, जी सर।
बहुत से पैरामीटर को देखना पड़ता है फॉर एनी check them or other classifications. बट यू
जी अभी।
कैन पहले आपको सैटेलाइट डाटा में एक पॉइंट मार्क कर देना है डिफरेंट डिफरेंट एरिया में जिसमें पॉसिबिलिटीज है बनाने के लिए. Then we can get the information from the contour lines, from the flow directions in the analysis. We can get from the hydrological tool में हम हमारा flow directions ऑटोमेटिकली क्रिएट हो जाएगा. तो उसमें से हम एनालाइज कर सकते हैं कि डिफरेंट डिफरेंट फ्लो डायरेक्शन किस किस एरिया में आ रहा है. और अगर 10 एरिया में फ्लो डायरेक्शन आ रहा है ड्रेनेज का, तो उसमें से कौन सा जगह सुइटेबल है फॉर क्रिएटिंग सम चेक डैम और सम लूज बुल्डर एलबीसीडीज और एनी डैम. तो साइट एनालिसिस के लिए ये अच्छा है. आप ऐसे काम अभी चल रहा है शायद कुछ डैम कंस्ट्रक्शन के लिए.
जी सर, डैम का तो चलता ही रहता है सर।
हम्म.
अभी चेक डैम हमारा यहाँ पे राजस्थान में बन रहा है,
हम्म.
जोधपुर में,
हाँ, देखिए मैं
विद्रोह का नाम से।
एक एग्जांपल देता हूँ. अभी अभी आ रहा है ना मेरा स्क्रीन? स्क्रीन इज विजिबल नाउ?
ये सर विजिबल है।
हाँ, वन जस्ट मिनट. देखिए जैसे हमने भी एक बनाया था एलिवेशन को लेके, ये आपको दिखा रहा है?
ये सर दिख रहा है सर।
दिख रहा है ना? ये हमने
जी
सब
सर।
कैचमेंट एरिया है. इसमें सब एलबीसीडी, ये जो आपको ब्लू कलर दिख रहा है ना, ये सब एलबीसीडी है, लूज बुल्डर चेक बॉन्ड है. तो छोटा छोटा जो फॉरेस्ट सॉइल को कंजर्व करने के लिए हमने 22 एलबीसीडी क्रिएट किया है फॉरेस्ट एरिया में. तो ये सब ड्रेनेज पैटर्न है. ये हमारा सेटेलाइट डाटा आ गया. देन सम एलिवेशन इंफॉर्मेशन मैंने क्रिएट करके हमने एक हिप्सोमेटिक कर्व क्रिएट किया है. So this is a hypsomatic curve from point, this point, this is a upper level point to lower level point. So ये upper level हो गया. अभी upper level में 389 मीटर है एलिवेशंस. देन लोअर में इतना है. तो अगर देखिए इसका अगर एलिवेशन शार्प जा रहा है, मतलब हाई एलिवेशन है, तो इसमें ये जो एरिया है, ये जो एरिया में थोड़ा फ्लैट एरिया है, तो इसमें कुछ स्पेस या कुछ भी प्लेन एरिया मिल जाएगा. तो हम ग्राफ को देख सकते हैं, एलिवेशन कंटूर को देख सकते हैं, और इससे आपको हिप्सोमेटिक कर्व क्रिएट करके भी देख सकते हैं. इसमें आपके टोटल एलिवेशन इंफॉर्मेशन आ रहा है. लाइकवाइज ऑल दिस इंफॉर्मेशन सर, ये सब दिया है. ये सब वाटर सेट बेस्ड काम किया है.
यस सर।
तो इसमें तो हम चेक डैम कर नहीं सकते, ये तो सब फॉरेस्ट सॉइल के लिए. तो इस एरिया जो है, इस एरिया में पॉसिबिलिटीज है. नो हैबिटेशन भी नहीं है, कुछ विलेज भी नहीं है. तो दिस टाइप ऑफ हमने भी ऐसे भी स्टडीज किया था अभी रिसेंटली. तो किस एरिया में चेक डैम करना है, किस एरिया में एलबीसी करना है. तो ये पॉसिबिलिटीज है, ये ग्राफ बता रहा है. तो इसे ही हमको चूज करना पड़ता है. और फील्ड विजिट भी चाहिए, ऐसा भी नहीं कि विदाउट फील्ड विजिट वी कैन गेट इंफॉर्मेशन. मैं और एक आपके पास अगर एलिवेशन है तो एक चीज कर सकते हैं. एक को आपको सैटेलाइट इमेज देखना पड़ेगा, गूगल अर्थ इमेज देखना पड़ेगा. सेकेंड, आपका जो कंटूर का वेरिएशंस आ रहा है, तो किस जगह में क्लोजनेस है, किस जगह में थोड़ा गैप आ रहा है. तो जब गैप आ रहा है कंटूर में, तो उसका एलिवेशन धीरे धीरे कम हो रहा है. और आपका डेम डाटा है तो डेम डाटा से और टीन डाटा से भी आप क्रिएट कर सकते हैं. देखेंगे नेक्स्ट हम एक दो. ओके.
ओके सर, थैंक यू सर।
थैंक यू. ओके, और कुछ क्वेरीज है किसी का? नहीं.
सर ये प्रेजेंटेशन शेयर कर सकेंगे आप सर
हाँ
प्लीज?
हाँ, मैं शेयर कर दूंगा, अभी तो टाइम नहीं था, मैं कर दूंगा, व्हाट्सएप में दे दूंगा। ओके।
ओके सर, थैंक यू।
ओके, थैंक यू।